Okay, in this video, we're going to show how to actually use matrix algebra to obtain the least squares estimates. So the first thing we have to do is create the X matrix that has the covariates as columns. And for that, we're going to use a function called cbind. So cbind takes vectors and joins them into matrices. So here we would have t and t squared. Now we also need a vector of ones. And in R, if I just put a 1 there, it will automatically realize that what you really mean is a vector of 1s and do it for you. Now, if you want to be very careful, you can use the rep function to do that, but it works if you just put a 1 there. Okay, but here we have 3 vectors of length n, and that creates our matrix, the cbind matrix. So we can take a look. There it is. You can see the column of 1s, the t's, and the t squares. Okay, so that's ready. Now, the next thing we want to do is compute the say the residual sum of squares for any given beta. So that is also pretty easy to do. We're going to define a arbitrary beta here. So let's just so we have an example. Let's see. Let's say it's what we used earlier, 55, 0, and let's just put a 5 there and make it dimensions 3, 1, so that we can multiply it by x. So now we can, for example, create the x times beta. We can do that using the matrix operation, the multiplication, which is not this. That's for scalars. For matrices, we use that. All right, so x beta, you would write like that. So the residuals are simply y minus that. That's simple. Those are the residuals. It's a little bit easier to write than what we did before. Okay, so that the residuals we get like that. Now we want to get the RSS, then we just simply do transpose R, like this. All right, let's see how that works. Oh, I gotta define beta, of course. And we do that, and let's see if we get the same answer with that function we wrote in the previous video, RSS, with 55, 0, and 5 should give us the same answer. There it is. Okay, it's doing exactly the same thing, except now we're using matrix algebra. So now, one very quick point, important point to make is that we rarely want to write this in R because there's a faster function to do this. It's such a common operation that we have a special function written for this, and it's the cross prod function. If you just feed it one vector like that, it will, or a matrix, it just computes R transpose R. So you can see that gives us the same answer. Okay, it's faster and more stable. All right, next thing we're going to do. Now we're going to actually get the least squares estimates. We showed in previous videos the math behind it. There's a very important formula that we use, x prime x inverse x prime y. And we showed you that formula in a previous video. We're going to write it out in R now. So let's see how that looks. So that's going to be our estimate. So I'll call it beta hat. And we're going to do x prime x. So that's x prime x. I'm going to write it out like this so you see it. Then we'll put the cross prods in. We want the inverse of that. In R, the inverse is obtained with solve. So that's x prime x inverse. And now we multiply by x prime y. So that's x prime t gives us the transpose times y. And that should give us the beta hats. Let's see how they look. Yeah, they look very similar to the ones that we got with fit. See that? That's what fit is doing in the background. Okay, now a couple of things. We said cross product is better than x transpose x. You can also use it with x transpose y. So the way I would actually write this is like this. Oh, no, yeah, solve, and then cross prod x, and then cross prod x, y. Okay, so that's the same thing. We can check if in fact it is. And there it is, same numbers. Now this approach will work in most situations, but solve is actually somewhat unstable, and there's a more stable way I want to show you. We're going to go into the details of this later, but I do want to show you how it works, just so that you are aware. It uses something called a QR decomposition. So I'm going to show you code to do this very quickly. I decompose X into two matrices Q and R, and then you're able to use another function, backsolve, that is more stable than the solve one. So we can write R and what is it? It's R and it's a cross prod of Q and Y, and you will see later what this all means, but I just wanted to show you that you get the same answers. And again, backsolve is more stable than solve.